Hello driving intelligence community. This is an exciting video for me, and it should be especially interesting for those who own a Dodge Ram 1500 pickup that still has a clutch driven cooling fan. Now in the past I've done a lot of videos, and I'll link the playlist below, that shows how I've improved the fuel economy of a 10th generation F-150. Mine's a 2002 model with the 5.4 V8 engine. As I've gone through improving the fuel economy, what I did not do initially was track how much fuel economy improvement I got with each change I made. Well, I started doing that recently. You'll see I did it with towing mirrors, I've done it with spoilers, but this time I've got a 2004 Dodge Ram 1500 Hemi 5.7 liter engine that has a clutch driven fan, and I'm making the change to a Flex-A-Lite unit, and it's a singular change. So you're going to see what the fuel economy improvement is moving from the clutch driven fan to an electric cooling fan, which will definitely show the benefits, whether they exist or not, of this conversion. Now, as usual, I always include all the links to these products I use in the description below, and while you're down there, please make sure that you hit that thumbs up and comment. And now let's take a look at this kit. And here are all the parts laid out in preparation for installation. Everything was well packaged, everything looks good, looks pretty heavy duty. Here are the instructions that are pretty straightforward. The only thing that looks like it gets a little complicated, which is definitely achievable, is the electrical connections, but we'll see that when we get to that point. I rented a fan clutch removal tool from Advanced Auto, and they take it back, so it's no big deal. But what I had to do was tighten up the belt with a breaker bar and a tensioner. You can see it's being held in place now, fully tight. What I did was tap this wrench with a big hammer, and now it's loose. In the instructions, it says that these studs are supposed to be flipped around, and somebody's worked on this before, so I'm having to take the nut off to flip this stud to this side, because the cooling fan shroud actually attaches onto this with a supplied nut to hold all this together. Important step I should have done first was to drill a hole for these wires. I don't think it said anything about that in the instructions, but maybe I missed it. In any event, I drilled the hole, pulled them through, and now these wires have got to be routed up to stay out of the way of all the machinery and the fan, up to the controller, the VSC, which is at the top of the radiator support. One of a few problems with this kit is the installation of the coolant reservoir. Although the tank went in without obstruction, there is one area where it appears Flex-A-Lite left out a bracket or a piece of a bracket. The electrical portion of the install is pretty straightforward. Here you can see I mounted the variable speed controller on the top of the AC condenser fan shroud, providing good access to all of the required points of connection. The positive and ground were routed a short distance along the fender behind the battery. The fuse box is a few short inches away, and this location also gave good access to tap into the AC compressor, providing a signal to the variable speed controller to turn on the cooling fan when the air conditioner is in use. The only other area that caused some difficulty was the fuse tap. The fuse tap provided with the kit was too wide for the Ram's fuse box, so I had to use a file to reduce the size of the tap to fit in the selected fuse slot. After filing down that little connector, I was able to get into the slot for the fuse, and this is the signal wire going back to the VSC to give indication when you turn the key on that the fan should operate because the engine is operational. Now with all the wiring in place and the controller mounted, what I'm going to do is start at the vehicle after zip tie everything in place so it doesn't get pulled into the engine, and then we'll set the temperature on the VSA to turn on with the appropriate thermostat setting. During editing of this video, I realized I did not show the location of the temperature probe, which gives indication to the variable speed controller when it should turn on. The temperature probe runs from the variable speed controller to the location closest to where engine block water enters the radiator. That's how it gets an indication of what the actual temperature is inside the block. It's gently pushed into the fins of the radiator, and that gives the VSC all the information it needs to do its job. Everything's connected, and with the engine running, you can tell that the VSC is properly connected with the red light. First thing we did was turn on the air conditioning to make sure that it activates the fan, and it absolutely did. Now I'm waiting for the temperature of the engine to get up to full operating temperature, and I'm using my blue driver. And here you can see that we're up to 149 degrees. I need to wait a little bit longer until it gets up to about 185 degrees, and that's when I want the fan to initially start. Before I get into the results, here are a few photos showing the final installation of the Flex-A-Lite kit. I mounted the variable speed controller on the top of the stock fan shroud on the driver's side of the truck. This is the adjustment screw that allowed me to set the temperature at which I want the fan to turn on. The Flex-A-Lite fan looks almost OEM, and here is the final installation of the coolant reservoir. First, let's review the EPA highway rating for this truck. The 2004 Ram 1500 pickup is rated at 12 miles per gallon city and 17 miles per gallon highway. Not very good. I tested the Ram 1500 on the same highway route used for all my 10th gen F-150 tests, Highway 85 between Greenville, South Carolina and Atlanta, Georgia, at a steady 65 miles per hour. This route does have some hills that will impact results. I filled up with 87 octane fuel at the same fueling location for both tests. With the clutch-driven cooling fan, the Ram Hemi achieved 16.9 miles per gallon, and after installation of the electric fan, the Ram achieved 20.9 miles per gallon, an amazing 4 mile per gallon increase. That honestly blows my mind, an incredible improvement. Bear in mind this is one test that I have not duplicated, but the results clearly indicate a significant improvement is made with an E-fan conversion. Let's make a few calculations with these numbers. If the average person drives 7,500 highway miles per year and the average cost of 87 octane gas is $3.50, these results will save $297 per year. The current price of this fan kit, linked in the description of this video below, is $305 on Amazon. So installation of this kit could have a payback of just over 1 year. Those are incredible results. And remember, the results are not only increases in fuel economy, you will have better overall performance with this conversion. These tests take some time to perform and create a video, so please be sure to give me a like and comment what you think of the results. This pushes my videos onto other viewers, and until next time, thanks for watching Driving Intelligence.